The camera is going. Let's go. Let's get focused, please. Thank you, Abdullah. We're getting focused. Everybody. All right. So we're going to look. The first thing we're going to look at is some simple graphing. Okay, just the idea. Now let's say that I have a set of data. I'll put a set on the board and we'll graph them. Okay, so take out, you don't need graph paper, just on a piece of paper. Okay, just on a piece of paper, you're going to take that. So get out some paper, get out a pencil, and let's do this. Okay, so let's say I have a set of data. We'll say it's going to be, the x-axis is going to be time, and we'll say it's seconds. And in the y-axis, it's going to be distance, and we'll say it's meters. Okay? Is that good?
Yeah.
Yes? Now, what we'll say is, we'll say that it's going to be, the time is going to be 0, it's going to be 2, 4, 6, 8, 10. So every 2 seconds, you're going to take data, right? All right? And you're going to put in the values. Okay, you're going to put in the values. And remember, you're going to draw your best straight line, correct?
Yeah.
Okay. So this is going to be 0. You're going to go 0 meters. And you're going to go 7 meters in the first 2 seconds. Then you're going to go 12, right? Then you're going to go 20. Then you're going to go
27.
you're going to go, say 28. Sorry, 28. And then you're going to go 32. Okay? So graph that. Okay? I'll do it on the board, but you graph it on your own paper. I'll make a rough graph on the board. Okay? Is this coming off? Can you see this?
Yeah.
Okay? You can see that?
You can see it. Yeah, there.
Better? Okay. Okay.
Is time on the x-axis?
Time, well, the x-axis is always the horizontal. See how it says the x is the x is always on the left. This is always the x. That should be basic to everyone. This is always x. It's always xy, always. Right? Correct? Okay. So let's look and see. Make sure this is all. So we'll raise this up a little bit. Okay. Yes?
How do you get the distance? Is it just
I'm just giving it to you. I'm giving you the distance. Excuse me?
Is it just random?
Is it what?
Did you just make it up?
Yeah, I'm making it up. I want you to graph the data. I want you to make a graph. So this is going to be, so I'm going to do it up here on film, and you can look at it later, but I want you doing your own work, okay? So graph it, okay? Okay, let me get a ruler. Okay, let's look at the board. Okay, you can take that data down and finish it later at home, right? Okay. Now, so you can see that I made the best straight line through the data, correct?
Yeah.
You can see that the data is a little off, because this should be going, 7, and then 14, 21, 28, right? You get it?
Yeah.
So it's a bit off, isn't it?
Yeah.
Okay, so then how do you find the slope of this line? How do you find the slope of this line? Now, remember, this is key. Are you listening to this?
Yes.
This is on video, so you can re-look at it. Okay, you ready? You plot your data, correct? Before you draw the line, you plot your data. So that's the data, right? The dots are the data, right? Right? Okay. You plot your data. You draw your best straight line through the data, correct? Do you see that that's the best straight line through the data?
Yes.
Now, you use that line. You use that line to find the slope. You see? You're not using your data. You're using the best straight line through the data. You see that?
Yeah.
When
Abdullah.
you do the slope, are you also supposed to find the speed? Right.
No. Just the slope is the speed.
Right.
Yeah, and I'll show you how you know that.
Okay.
Okay, now, I'm not going to use a ruler to draw. You should draw a triangle, right? My arm is hurt. It's hard for me to use a ruler. Okay, so what you do is you draw a best straight. You draw a triangle, right? So here's the line. So draw a convenient point. Okay, a convenient point. Okay, let's say that's it, right? Right there. Okay. That's a convenient point, and then drop it down to here. Okay? Yes? Is that okay?
Yeah.
So then you take your ruler, and you draw a ruler. You draw this line over there. It's a pretty straight line, actually, isn't it?
Yeah.
And then you draw the line straight down. Okay? And then you say to yourself, rise over run. Okay? So M is the slope. We'll change M in a moment. Okay? Am I on the camera?
Yeah.
Okay. So you say the rise over the run, right? So that's going to be, it goes from 0 to 5, 10, 15, 20, 25, correct?
Yeah.
Yes? Okay. So it goes to 20, it goes 25, what? Rise. 25 meters, right? Correct? 25 meters over the run. 1, 2, 3, 4, 5, 6, 7. So it's going to be like 6.8. Is that okay? Can we agree on that?
Yeah.
You're approximating it. Is that okay?
Yeah.
So 6.8 seconds. Now, what is, take out your calculators. Take out your calculators. And what is 25 divided by 6.85?
3.649.
What is it?
3.64.
8.64?
3.649.
No, right, but don't,
Round it.
you want to use at least 2, no less than 2 and no more than 3 significant figures. Okay? You don't want to write down everything on your calculator. Okay? Excuse me. Do you understand? Just 2 or 3 is fine. 2 or 3 is fine. So what would you say? 3. Go ahead. What would you say? What is it?
3.64.
3.64 meters per second. Is that on the camera? Okay. What happened to my videographers over there? Okay. Okay. It's not bad. That's not too bad. Okay. So it would be 3.64 meters per second. Okay, now. So let me ask you this. Are you ready? Shall I write the question on the board? You ready? I'm going to write a question on the board. Okay? All right. You ready? What is the slope of the line from a distance versus time graph called? What is the slope of the line from a distance time graph, right? That's what this is. This is distance versus time, right? Yes? Right? What is the slope of the line from a distance time graph called? What is the slope of the line from a distance time graph? What is it called? Okay, what is it called? Yes.
Speed?
Speed. Yes, that's correct. Speed. Right? Right?
Yeah. I'm trying to find out the slope of the
Speed, right? It's speed.
Yeah.
Correct? Or velocity, right? If I said to you, find the velocity from the distance time graph. In other words, is that speed or could you argue that it's velocity? Is it a positive slope?
Yeah. Yeah.
So does it have magnitude and direction?
Yeah.
What's the direction? Positive, right? Right? Let's say, how do you know it's positive? Well, let's say this. What if this is positive? What would this be?
Negative.
Negative, right. You get it?
Yeah.
So the answer would be it's called velocity. The slope of the line is called the velocity. Does that make sense? Does that make sense?
Yeah.
All right, now. Now, let's pretend, instead of making another graph, we're going to keep this graph because it's really cool. It's a very good graph, okay? But we're just going to kind of wave our hands here a little bit. And I'm going to say this is actually that's actually velocity. I'm saying it's velocity. That column is velocity, not distance. Is that okay?
Yeah. Yeah.
I'm just changing my mind. Is that all right? What else do I have to change, though? The Y. Very good. You should get rashes more often. That's very good. Very good. Excellent. I like that. How do you feel? You feel all right? Excellent. What is it? You feel all right?
Yeah.
Excellent. Nothing worse than an itch, man. They are the worst, aren't they?
Yeah.
Ugh. Ugh. Like your back itches, you can't scratch it. You just,
You need to like a back at your feet.
Yeah, I'm telling you, it's the worst. Okay, so now, this is going to be, I'm going to change this, right?
Yeah.
So it's going to be meters per second over second, which is the same as what?
Meters per second squared.
Magician.
Wow, very good. Excellent. I'm very impressed. Meters per second squared. Meters per second squared. Okay? And now, here we go. You ready?
Yeah.
Drum roll, please. I didn't say, I want you to demonstrate what it sounds for a herd of horses to come galloping up the canyon.
You didn't say Simon Says.
All right, that's enough. Okay. enough. All right, put the horses in the stable. Okay. Horses don't belong in a classroom. Okay. From a velocity versus time graph. Cool. What is the slope? What is the slope of the line from a velocity time graph called?
Sure. Yeah.
Try. Craig! Oh my God! Well, you should have said it! Now you were thinking! Man, I'll tell you, late on the buzzer, man! Craig's back there. Yeah! Thanks for playing.
Hey, quit playing.
Excellent. Excellent. Yeah, the acceleration. Right? Does it make sense? Well, let's see if it's acceleration. Well, look, guys. First of all, what's a dead giveaway? Well, I have the unit labels for acceleration here. Dead giveaway. But, and I got to change this. All right, fair enough. This is meters per second squared. I got to change that there too. But the idea is that what's going on? Isn't the velocity changing relative to time?
Yes.
Right? Right?
Yeah.
Right? So the velocity is changing relative to time. So m, right? So in other words, a equals, what did we say? What did we say? We said the change in velocity over the change in time. So here's the change in velocity. It goes from 0. This is the change in velocity. It goes from 0 to what? What's that?
Wait.
Does it go from 0 to 25? You see that? Right? So isn't that the change in velocity? Right? So that's the change in velocity over the change in time. It goes from 0 to 6.8. Right? Right? This is looking a little bit crazy. Okay? This is a little bit crazy. Little crazy? Yeah!
Yeah!
All right. You should have seen it this morning. My first block, I thought that I was in like a hospital trauma recovery ward. This is how they looked at me. You ready? You ready? This was my class this morning. Are you ready? This is my class this morning. You ready? I'm going to imitate my class this morning. You ready? You ready? You ready? You ready? You ready? Okay, you ready? You sure?
Yeah.
Okay, you ready? Okay. It was unbelievable.
Can we do it? Can we do an example?
It was like incredible.
I didn't want to start. Everyone should do it.
They were horses. They were like horses in a barn, sleeping with their eyes open. Okay, so you see that this is going to be m. That's going to be that's going to be acceleration. Okay, that's going to be acceleration. And that's going to be the change in velocity over the change in time. Here's the change in velocity, right? Here's the change in time. So the change in velocity, I'm going from 0 to 25. And then the change in time, I'm going from 0 to 6.8. Make sense? Yeah? Do you understand how to get slope a little bit better?
Yeah.
Yes?
Yeah.
Better? Okay, good. All right. All right, this is going to be review
Part 2.
is this part 2?
Yes.
Yeah,
Last class we did part 1.
Yeah, we did part 1. Motion.
So this is
Part 2.
so this is motion review
Part 2.
part 2. Okay. We got it. I'm going to stop and then we'll regroup. We'll talk about what we want to talk about the next one and then we'll start another one. We'll try to get 2 more done.
Okay.
Between now and the end, okay? All right?
Yeah.
All right. We're off.